Okay, in this review problem, we're going to go over the definitions of one-to-one, onto, and bijection. First off, problem number 28. Define a function with domain 1, 2, and 3 and codomain 4 and 5, which is one-to-one. That is impossible. So this one is impossible. The reason that's impossible, and I'll just kind of draw a picture here. So if I have 1, 2, and 3, and the codomain is 4, 5, well, 1 can go to a number, 2 can go to a different number, but 3 would have to go to either 4 or 5. There's too many things here and not enough things over here. And so it's impossible for me to draw this without two different points in the domain going to the same point over in the codomain. So that's impossible. If possible, define a function that is onto. Well, I just did that here. So the way that I would define it to be onto would be let f of 1 be equal to 4, let f of 2 be equal to 5, let f of 3 be equal to 4, and that would define a function that is onto from the set 1, 2, 3 to the codomain 4, 5, because every point in the codomain gets hit. Number 3 is impossible. And the reason that's impossible is because if it's a bijection, it has to be both one-to-one and onto, so that can't happen. Now, for the one that was onto, this is one possible solution. Obviously, there's plenty of ways that a function could be defined so that it's onto the codomain here. The problem only asks for one of them, and so this is one possible way to do it. All right, 29. If possible, define a function with codomain 1, 2, 3, with domain 1, 2, 3 and codomain 4, 5, 6, which is one-to-one. Okay, so this one is actually fairly straightforward. So the picture, and let me do the picture first. Here's 1, 2, 3. Over here is 4, 5, 6. So as long as we have something so that no 2 points over here end up at the same point over here, it's one-to-one. So if I define f of 1 to be 4, f of 2 to be 5, and f of 3 to be 6, that is a function from this domain to this codomain that is one-to-one. Also, it's onto. Every single point here is hit. There's no point that's left over. So no 2 points over here go to the same point, and no point over here on the right is left over. So it is one-to-one and onto, and therefore it is a bijection. So this function answers all 3 of them. Now, if it's a bijection, it has an inverse function. So f inverse of 4 equals 1. 4 goes uniquely back to 1. F inverse of 5 goes uniquely back to 2. And f inverse of 6 goes uniquely back to 3. Now, parenthetically, that's why this function that we saw earlier is not a bijection. Because I can't, if I try to go backwards from 4, I could go to 3 or I could go to 1. So this is not this function does not have an inverse. It's not a bijection. This one, there's no doubt about it. This is a bijection because 4 can go back to 1 and there's no doubt about it. 5 goes back to 2, 6 goes back to 3. So that is a bijection. Okay, lastly, let's take a look at problem 30. Okay, let's define a function that's one-to-one. So this one is not too bad. 1, 2, 3. The codomain is 4, 5, 6, 7. And so that would be a one-to-one function. No 2 points over here end up at the same point over here. So f of 1 equals 4, f of 2 equals 5, f of 3 equals 6. That is a perfectly fine one-to-one function. However, it's not possible to make this an onto function. If I have 3 points over here, I have at most 3 images over here, but there's 4 points in total, so 1 always has to be left out. So this is impossible. You can't do it onto. which means it can't be done as a bijection either. And the problem is that if I try to define an inverse function, 4 goes someplace, 5 goes someplace, 6 goes someplace, but 7 has nowhere to go. F inverse of 7 would not be defined the way that I drew the picture here. So that is impossible to draw a bijection like this because there's too many things over here in the codomain and not enough things over here in the domain. So this was an exercise in just simply knowing the definitions of one-to-one, onto, and bijection. And before I close the video, I just want to mention parenthetically, it is perfectly fine to define a function like this, kind of listing out the elements. So f of this number is this, f of this number is 5, f of this number is 3. Ordinarily, you think of f of x as like x plus 3 or f of x equals x squared or something like that. Here, I've listed out the things, and that's a perfectly legitimate way of defining a function if I have a domain that has only finitely many elements.